kids, Miss Kulkarni here. In this video, we will continue with organic chemistry. And in fact, we are going to find out how to name alkenes and how to draw the structures if we know the name for the compound. But before that, let's go through some rules which we need to remember while naming the alkenes. Step number 1, we have to make sure that we know the parent name for that molecule. And how do we find out? That's simple. We just look for the longest possible carbon chain in a given molecule. So here's the deal. Once you find out the carbon atom number, we can find out the root name. Like for example, if we know that longest chain has 5 carbon atoms and it has a double bond, the name will end with ene, of course, and it will be pentene. Second rule, every single alkene, any alkene, will always have the ending name as ene, E-N-E. And then about numbering, we have to make sure we start counting so that the carbon atom with the double bond, that gets the smallest least number. After that, we will look for any side chains present. And then we are going to number the carbon atom to which it is attached. This is actually almost similar to what we saw in alkanes. Alright then, are we ready to work on some examples for naming alkenes? Let's look at our first example. We got a straight chain of 5 carbon atoms. 5 stands for penta and we have a double bond, so our compound will be pentene. And then we need to work on numbering. Let's see how can we number this compound. One way to number the compound is starting from left to right, and second way to number this compound is going to be from right to left. And let's find out which one is going to be the correct method. Remember our naming rules for alkenes. If you are going to number from left to right, the double bond comes at position number 2, and versus if you are labeling from right to left, the carbon atom which has double bond is number 3. We need to make sure that the carbon atom gets the least number. That means we need to cross that out, and the correct answer will be 2-pentene. Now you may find in some places the name written as pent 2 and then ene. It's basically the same thing. Both names suggest that at position number 2 for carbon atom, we have a double bond in that alkene. Let's move on to example 2. And again, if you see, that's going to be 5 carbon atom chain. But if you notice, we got double bond over here and one more in the compound. So we got 2 double bonds in this compound. That means it will be a diene. So our compound name will be penta and it will be diene. Di stands for 2 and of course ene stands for double bond. And phi is for straight chain. It's that simple. In order for carbon atom to get least number, I know I need to start numbering from left to right here. So in that case, my one of the double bonds start at position 1 and second one begins at position 3. So I get 1,3-pentadiene as the name of the compound. And one can also write down that's penta 1,3-diene. Each of the word in this name has a specific meaning. Ene, you already know, stands for alkene. That means there is a double bond there. Di indicates we have 2 double bonds. Then we got 1 and 3 here. Those are the locations for double bond. Don't you think it's getting easier? Let's move on to our next compound. And I'm going to number this from right to left just because the carbon atom with double bond should be getting the least number. And then we also have a side chain. This side chain has 2 carbon atoms. So you can guess it. It's an ethyl group. So how do we name it? The straight chain has 4 carbon atoms. So it is going to be a butene. The position of double bond is at carbon atom number 1, so it's 1 butene. And then I got at position 3 ethyl group, so it will be 3 ethyl and then 1 butene. Is that simple? How about next one? Check my numbering. I'm going from right to left to make sure that the carbon atom with double bond gets the least number. And of course the side chain I have is methyl group. So what's the name going to be? Check your answers. It's 4-methyl 2-hexene, or we can also write down 4-methyl hex 2-ene. Are we ready to work on some cycloalkanes now? It is basically same as we did cycloalkanes. Only difference is we need to make sure that we are writing the location of double bond, and then if there's a substituent, we number that carbon atom also. So the first example here is a ring with 5 carbon atoms. 5 goes with penta, and we got a double bond, and it's a cyclic compound. So it will be cyclopentene. How about numbering? I need to make sure the double bond gets the least possible number. So that's what I got for numbering, which means my double bond is beginning at 1 position. So it's 1 cyclopentene. Sometimes if it's 1 double bond and cyclic compound, we don't need to even write down the location of double bond. But it's just a good idea to write down. Look at the next compound now. We got again a cyclic ring with 5 carbon atoms, but now we got 2 double bonds. So how do we name the parent compound? It's cyclic, so it's cyclo. It's 5-member ring, so it is penta, and we got 2 double bond, so it's going to be di and ene for having the double bonds. So each of the term has a meaning. And now next thing is we need to start numbering. So my double bonds are beginning at position 1 and 3. So it's 1,3 cyclopentadiene. Or I can also write down at cyclopenta 1,3 diene. Let's see if we can get the answers for the remaining 2. Here is the numbering for carbon atoms. And here is the answer. 2-methyl 1-cyclopentene. And we can of course write down 1-cyclopentene as cyclopent-1-ene if you prefer. One more to go. So look at this. I already got the numbering for carbon atoms, which the double bond carbon got number 1. And then we also have a side chain, which is cyclopropyl. Remember, if you get 2 rings, always the smaller ring is considered as a substituent there. So what is the parent name? We got a ring of 6 carbon atom, so it is going to be hexa, and since we got double bond, it will be hexene. Double bond begins at position 1, so it's 1-hexene. And then we got the substituent cyclopropyl in position 3. So it is 3-cyclopropyl 1-hexene. And now we are going to draw the structures of alkenes when we got the name. So let's see how we are going to do that. We got 2-methyl pent-2-ene. Look at the root name. It's pent. Pent means 5 carbon atoms. So I'm going to begin by writing a chain of 5 carbon atoms. Then I have a double bond here at position number 2. So I'm going to number whichever way I feel comfortable with. That's 1, 2, 3, 4, and 5. At position 2, I got a double bond. So that's my double bond. So I got pent-2-ene. And at position 2, I have a substituent, which is this position here, which is a methyl group. So I'm going to put the CH3. Now the rest of the part is to make sure we got enough hydrogen around that. And you have 2 choices. You can actually draw the bonds and show each of the hydrogen, or you can just count the hydrogen and write the hydrogen number. I prefer myself to write down the number of hydrogens instead of drawing. So that is CH3. Then over this carbon atom, be careful. All the 4 bonds with carbon are satisfied. So it will not take any extra hydrogen. Let's look at the third carbon atom number. We got 3 bonds satisfied. That means we need one more hydrogen there. For fourth one, we got 2 bonds there. That means we need CH2. And for number fifth one, we need to get all 3 hydrogen atoms. So that's what we got, 2-methyl pent-2-ene. Is it getting easier? Let's work on the next one. We got hexene here. That means we need to get 6 carbon atoms, chain. So here is my chain. And then I need to start numbering. So that's my carbon atom number 1, 2, 3, and so on. The double bond is on carbon number 2. So that's my hexene. And at position number 3, we need to get ethyl group. So that's my number 3. Ethyl group is CH2, CH3. And now the only part left is to make sure we get exact number of hydrogen atom. So there it goes, 3. We got 3 bonds. It's always good idea to count the number of bonds because carbon can only have 4 bonds. So I got 1 hydrogen there. Look at this carbon atom. Everything is all full. 4 bonds are there. So no extra hydrogen. Over here, we need to get 2, and over here, 3. So that's our structure for 3-ethyl hex-2-ene. Now let's work on one more cycloalkene. So this is cyclopentene. Penta stands for 5. That means we need to have a cyclopentane ring. When you're drawing structures for cycloalkanes, you can just draw the rings. You don't need to write every time carbon and hydrogen number. You can if you like to, but I prefer not to. It will be a time saver for you. So pent-1-ene. So I'm going to number whichever I want as number 1. So that's my number 1. That's 2 and so on. So at position 1, I must be having a double bond there. So that's my cyclopentene. And now I got a substituent at position 1, which is a methyl group. So that is CH3. So guess what? I am sure you guys can name any given alkene now. And if the name is given, I am positive you will be able to draw the correct structure. Alright guys, I hope you enjoyed the video. I will see you again in next video. Until then, bye bye.